This is the M7 paper 2 from November 2023 from CCEA. Let's look at question 1. Here are some numbers. From the numbers given, write down a square number. Well, you can look your way through and find what we have. At 49 is 7 squared, so that's my square number there. A cube number, so 2 cubed is 8. We can start there, so that would work. And then a triangular number. So triangular numbers are a wee bit kind of more difficult to kind of suss out. So it's ones that kind of make a wee triangle. Maybe other ways of working this out. So it'd be 1, and then 3, and then 6, and then 10. And you can kind of, so 1, 3, 6, and 10 I don't think are there. But they remind me of kind of snooker balls or pool balls whenever they're kind of set up. So 1, 3, 6, 10. Maybe I've had this worked out already. But you add one more each time, so it's kind of add 2, add 3, add 4. So you add 5, you get 15. 15's not there. You add 6, you get 21, and 21's there. So 21 then is our answer to that. Question 2. It takes 2 days to paint the outside of 6 houses. How long will it paint the outside of 5 houses? Well, it's 2 days for 6, so it'll be 1 day for 3, so for 15 then it's going to be 5. State one assumption you made in answering part A. Well, there's different things you can do, but maybe you know that the painters work at the same rate or that the houses are the same size. Question 3. Enlarge the shape on the grid below using a scale factor of 3. So I'm going to start here and hopefully it'll fit in. So this goes across 2 and down 2. So instead of going across 2 and down 2, I'm going to go across 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I think that goes to there. Same on this side. You can sort of see the symmetry. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's join those up. First of all, excuse me for rotating this round, it's just easier to rule the lines if we can do that. So we have that. And then these go down 2, so instead of going down 2, we're going to go down 6. 1, 2, 3, 4, 5, 6. Can't quite see the bottom of this because that's okay. One, 2, 3, 4, 5, 6, and then I suppose really just kind of the same again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and if we join those up. They get then what we need, and that's my U shape drawn there. Connor mixes red, blue and yellow paint in the ratio 4 to 2 to 1. He uses 10 litres of blue paint. He sells the mixed paint at a price of $18.25 per litre. Work out the total price of the mixed paint. Well, it's in the ratio 4 to 2 to 1, and it's red, blue and yellow. And so if he's 10 litres of this one, you see what's happening here? We've times by 5, so that's going to be 20, and then that's going to be 5. 20 plus 10 plus 5, so it's 20 litres of this, 10 litres of this, 5 litres of this, so that comes into 35 litres. And so we're going to do 35 times 18.25. Be careful of that in your calculator, obviously with the decimal point. But it ends up being £638.75. Question 5. A firm holds a Christmas raffle for 20 employees. The raffle tickets are numbered from 1 to 20. Ticket is drawn at random from the hat. What is the probability the ticket drawn is a number less than 10? Now be careful, I do mean less than 10, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8 or 9. So that's going to be 9 over 20. A number more than 15, so you don't count 14. Sorry, number more than 14, you don't count that. So 15, 16, 17, 18, 19, 20. So that's 6, and that cancels down into 3 tenths. And a prime number between 1 and 20, so this here primes 2, 3, 5, 7, 11, 13, 15 isn't, 17, and 19. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 over 20, and that cancels down into 2 fifths. Question 6. Julie collects 50p coins. 70 of these coins weigh 560 grams. What is the value of 880 grams of these coins? Okay. Let's see. So it's 50p coins, that's alright. We'll worry about the 50 in a wee second. So 70 of them are this. So if we do 560 divided by 70, 560 divided by 70 gives us 8. So 8 then grams is 1 coin. So if we do 880 divided by 8, it's going to tell me how many coins I have. And I believe then that's going to be 110 coins. And if each one is 50p, 110 times by 50 is 5500. Now remember, of course, that is in pence, so we want in pounds, so our answer then is going to be 55 pounds. Question 7. Ben and Orla share the cost of a meal in the ratio 3 to 1. The meal costs £64. Then Ben pays a taxi fare. Ben pays a total of £60. How much is a taxi fare? So we got to go 3 plus 1 here, and it gives us 4. And then 64 divided by that 4 gives 16. So 16 from the 3 to 1. We're timesing each of these by 16. So it means Ben has paid £48 and Orla has paid £16. If times is 16 by 3 there. I hope that makes sense. So if he's paid 48 and he pays £60 in total, 60 minus 48, and my answer then is 12. Question 8. Data is recorded about the age and treatment received by patients who visited a dentist on Monday. So patients under 30 or under, filling an extraction, over 30. What's the probability that one of these patients selected at random is over 30 and has an extraction? Over 30 and has an extraction. That's going to be 13. And then what's the total? 9 and 5, 14 and 13, 27. I think there's 33 of them. So it's going to be 13 over 33. One of the patients aged 30 or under is selected at random. What's the probability that this patient has a filling? So we're only dealing with these folks here, and there are 14 of them. What's the probability of a filling then is 9 over 14. A sketch of an irregular pentagon is shown. Calculate the value of x. So it's a pentagon. So we know the angles in a pentagon. There's a couple of different ways of doing it. So let's talk you through a couple of different ways. I know a triangle is 180, and I know a quadrilateral is 360. So I know a pentagon is another 180, and it's 540. Or you can use the formula, which is n minus 2, the amount of sides, times 180. But either way, it's 540. So I'm going to add up these. So I'm going to go 114 plus 70 plus 98 plus 48. And I'm going to add those up then on my calculator, and they come to 330. And if I go then 540, because all 5 add up to 540, take away 330, and that gives me then 210 degrees. Hopefully you're able to see that okay. Simplify x to the power of 5 all cubed. Well, in this scenario here, we multiply the powers, so we get 15. Use trial and improvement to find the solution to the equation. Give your answer correct in one decimal place. So we pick something sensible, I suppose, to start with. We're going to have x here, and then x squared plus x over 2. So I'm going to try maybe the number 3. And if I try 3, I get 9 plus 3 over 2, so 1.5, that gives me 10.5. And that then is too small. Let's try 4. 16. 4 squared is 16 plus 2, that gives me 18. And that's too big. 3.5 seems a sensible guess in between. 3.5 squared plus 3.5 over 2. I think whenever you work that out, you get 14, and that's too small. So we'll go a wee bit bigger, 3.6. Again, so what I'm doing, 3.6 squared, this is just on my calculator, plus 3.6 over 2, and that gives me 14.76. So I'm getting close to this 15 here. We're not quite there, but still too small. 3.7. So 3.7 squared plus 3.7 over 2, and that gives me 15.54, and that's too big. So we're good. We know it's either this one here or this one here, and the way you check is to find halfway in between this one and this one, so that's 3.65. 3.65 squared plus 3.65 over 2 gives 15.1475. That is too big, so I need to go to the lower one, and so it's 3.6. So my final answer then is 3.6. So this is question 12 then. Kate plays a game of throw the beanbag. She records the number of times she gets the beanbag in the bonus hole. Write down the best estimate of the probability that Kate gets the beanbag in the bonus hole if she continues throwing. Give a reading for your answer. Well, we want to choose this here, the one with kind of the highest number of throws, and that's our answer to that really. So it's going to be 104 over 200. And that cancels down then to 13 over 25. And the reason for that is more throws gives better estimate of probability. Kate continues her game and throws it a total of 300 times. Calculate the number of times you'd expect her to get the beanbag in the bonus hole. Well, we have 13 over 25 as our probability of that. So if you times that then by 300, that would work it out for you. And the answer then is 156. Question 13. The position of two airport control towers N and B are shown. What is the bearing of B from A? So I'm first of all going to join together my A and the B here. Just kind of helps me to work out this bearing. And then I'm going to do the north line in as well. Now the fact that a wee grid here is really helpful. So that's my north line there. And I want the bearing of B from A, which is put in bold. So you're going from A, so this is where our angle is. So I measure clockwise from north in this direction here. So I get my protractor and I set it on and I line it up as perfectly as I can. We have lines here, so that line needs to be running along this line here. Hopefully that makes sense. And this line's running exactly straight up and down, so as accurate as we can possibly get it. Let's see. So I think that, let me see, am I on the line? I think that's pretty much us on the line right now. So we're measuring from 0 here all the way around until we hit that, and that looks to be 150, 155. It's hard to see here on the screen, but it's 156, I think. But you want to try and be as accurate as you can. So 156 degrees is our bearing then from there to there. They normally give you 1 or 2 degrees either way, but you want to be as accurate as you possibly can. Part B, the two towers pick up a distress signal from a plane. The bearing of the plane from A is 110, the bearing of the plane from B is 050. Find and mark the position of the plane with a P on the diagram. So the bearing from A is 110. So I set my protractor back exactly in the same place as accurately as I can get it, right on the lines here, and the bearing I want then is 110. So again, I'm going from 0, there's 100, there's 110 there. So there's my mark there, and I join that then from A. Again, try and be accurate. So I have that. And then B is a bearing of 050. You can draw in your north line if you wish. Just by the way, this here angle there is 110, that's what I've just worked out. And here we're going for 050. It's a 3-figure bearing, that's why they put the 0 in front of it there. The third figure. 0, 1, 2, 20, 40, 50. So we have this point here. And again, let's line it up with a pencil here. Right on B. And we have that. And we're told to label where the plane is P. So that's my point P there. So that's that one. And that one has been done. Question 14. Pete orders cold meals and hot meals on Monday, Tuesday and Wednesday. On Monday he got 16 cold and 3 hot. He paid £74. On Tuesday he got 20 cold and 7 hot. He paid 112. On Wednesday he got 10 cold and 8 hot. Work out what Pete paid for his meals on Wednesday. So, don't know if you spot this, is going to be simultaneous equation. So we're going to go 16 x plus 3y gives 74. And then 20x plus 7y is 112. You can either make the x's the same or the y's the same. I think y's is probably a little bit more straightforward to me, so I'm going to times this one by 7. I'm going to times this one by 3. If I times it by 7, 16 times 7 is 112x plus 21y equals 74, then times 7 is 518. Times this by 3, 60x plus 21y equals 336. And then I'm going to take those away. That gives me, sorry you couldn't even see that, hopefully that makes sense what I've done there. 52x, take this away from this, it disappears, and I get 52x is 182. Now 52 doesn't go into 182, but it's not so bad. 182 divided by 52 gives me 3.5. So x in is 3.5 as I said, and then to work out what y is, we substituted in, maybe sub it into 1. So it's going to be 16 times 3.5 plus 3y is 74. 16 times 3.5 is, I think, then 56 plus 3y is 74. And you get 3y then is 18. I hope that's okay, taking away 56 from both sides, and you get y is 6. So then for Wednesday, 10 cold, so that's going to be 10 times 3.5 plus 8 times 6, because it's 8 hot meals and we knew the hot meals then cost 6. 10 times 3.5 is obviously 35 plus 48, and 35 plus 48 then gives us 83. Question 15 then, rearrange to make z the subject. This is a wee bit messy. We need to square this first of all, and you get x squared is y z, and then divide through by y, so it's going to be x squared over y is z, and then it's good to write it the other way around just as a final answer. Z is x squared over y. Finally, the probability that the first person to cross a footbridge in the morning is a child is 0.05. The probability that the first vehicle to pass onto the footbridge as a tractor is 0.12. Complete the tree diagram to show this information. So that's child. I don't know if you've seen this wee symbol before. Wee line above it means not child. So a child is 0.05. And if you take that away from 1, then you get 0.95. A tractor is 0.12. And that gives me then 0.88. Whenever you take it away from 1, 0.12, 0.88. So that's you for that. What is the probability that the first person to cross is a child and the first vehicle is not a tractor? So we want child and no tractor. So it's going to be this here times this here. So probability of child and not a tractor. Remember my wee symbol there for that. So a child is 0.05 and not a tractor 0.88. And again, put that into your calculator, you end up with 0.044. And that's the end of the paper.